Variables, in layman's terms, are letters or symbols that represent a value that often needs to be found. They are often daunting at first because math was predominantly numbers only before, but learning them is simple and necessary. We will be figuring out how to find these variables and how they relate to linear equations. Here we have two basic equations with a variable. This upper addition equation contains the variable x. Our job is to simply find out what the x stands for. To do this, we're going to simply subtract 3 from both sides so that the x is left alone. Now we have x equals 7 minus 3, becoming a simple subtraction problem. As a result, we have x equals 4. Not too difficult, right? Our next problem requires us to do the same thing, but this time we're going to do the opposite direction because we're starting off with a subtraction. Here's the x we need to get alone, so we add 4 to both sides of the equation. We then have x equals 6 plus 4, resulting in x equals 10. Now we have two more basic equations. The top one, 5 times y equals 15, shows that the variable isn't always x. To start off, let's combine the 5 and the y so that the 5 becomes a coefficient. It still means 5 times y. Similar to how we solved addition with subtraction, we're going to divide both sides by 5 so that y is alone. The resulting equation is y equals 15 over 5, meaning that y equals 3. At this point, I think you guys have got the gist of it. Because it's a division problem, we're going to be multiplying. So, we're going to put the 4 under the x so it becomes a fraction. Then, by multiplying both sides by 4, we're going to be able to get x is equal to 3 times 4, meaning that x is equal to 12. Now, we're going to start looking at combining variables of the same nature and power. In this first equation, you can see that both variables are labeled as x, and both have only a power of 1. Consequently, we're actually able to add up 3x and 7x in order to get 10x. At that point, you just simply divide both sides by 10, and then end up with x equals 1. Here in this bottom equation, we have a similar situation. However, this time, the y's are on different sides. Yet the same effect can be acquired simply by subtracting both sides by 4y. Now that we have 5y minus 4y on one side, this just means that we need to combine like terms. On the other side we have 0, because there was nothing left on that side. In the end, y equals 0. Now we're going to start looking at applying these variables to graphing purposes. So in this specific equation, y equals x plus 2, the variables give us points for the graph. So starting off with x equals 0, all we have to do is plug it into the original equation. How this works is the x is literally the x-coordinate of the point. So by plugging in 0 into the equation, we are able to find the y-coordinate. In this case, the first point is x equals 0 and y equals 2. Fast forwarding a bit, we get the points 1, 3, 2, 4, 3, 5, and 4, 6. Now that we've collected all these points, we just need to place them all on the graph and connect them with a straightish line. Doing so will give us the graph of the original equation. Here we have two different linear equations with two different variables. With these equations, we can find at what point the two graphs intersect. To do this, we're going to need to solve the equations simultaneously. This will give us that point on the graph. To do this, we should treat both equations like some sort of addition problem, where the numbers are stacked one on top of the other. If you would like, you can put an addition sign in front of the x to show that you're going to be adding the two equations together. In order to do this, you must simply work from top to bottom. Start by adding together the 2x and the x in order to get 3x, and then subtract the y from the bottom equation from the y in the top equation to just get 0. Finally, subtract 1 from 4 to finish off the equation. As an end result, we have 3x equals 3. By dividing both sides by 3, we get x equal to 1. This is only the x-coordinate of the entire point. So by plugging in x is equal to 1 back into one of the original equations, we will be able to find the y-coordinate. By replacing x with 1 in the second original equation, we'll get 1 minus y is equal to negative 1. And then we just simply solve for y. This gives us the y-coordinate, y equals 2. When looking at an equation that has a negative variable, just remember that a negative variable means negative 1 multiplied by the variable. So what we did in that equation was we just divided both sides by negative 1. With this problem finished, we now know that the point where the two lines intersect is 1, 2. This is only one way to solve this problem. Now we're going to look at a different way of doing it. So instead of lining up the equations, this time we'll do them side by side. Let's start by singling out the y on one of the equations. We get y equals 4 minus 2x. Now we're going to use this to replace the y in the second equation. We'll then get x minus 4 minus 2x in parentheses is equal to negative 1. We then make sure to distribute the negative sign properly to get x minus 4 plus 2x is equal to negative 1. Once again, we need to single out the x, but first let's combine like terms to get 3x minus 4 is equal to negative 1, and then 3x is equal to 3, leaving x equals 1. Now, just like last time, we're going to plug x into the original equation. We'll then get y is equal to 4 minus 2, meaning that y equals 2. The coordinate point is once again 1, 2. Finally, I'm just going to go over equations with no solution. See here that 3x plus 7y is shared by both equations, yet one ends in 17 and the other in 16. This means that there's no possible answer where both equations share the same intersecting point. This means that the answer is no solution. I really hope this lesson helped. Thank you for watching.